So now in this video we're going to make another circuit with the LM358 dual op amp. So there's two op amps in one integrated circuit. And here's another thing you can see that's nice about it. We're going to use a pretty low voltage. It's 5 volts. We could go down to 3 volts. There's a setting on the, as far as the integrated circuit is concerned, there's a setting. If I move these jumpers, I can make these output 3.3 volts, but we're going to stick with 5 volts because it doesn't output the full power supply voltage. It does go down to the negative rail though. You can go to 0 volts. And then LEDs have voltage drop. So that takes away a lot from 3.3 volts between the two of those. But in any case, let's zoom in, and it's probably going to be hard to see, but the main thing to this circuit is this little jumper. There's a little piece of wire there. So let's go over the pin layout for the op amp again. So top pin there is the output of 1 op amp. The inverting input, the negative symbol on the schematics, is right below it there. And then the non-inverting input is right there. That's the plus sign when you're looking at a schematic. The pin layout on the right side is the same. We could just slide that right over, and the rest of the wiring and would work exactly the same. So output, inverting input, negative symbol, and non-inverting input, positive symbol. So that is the bulk of the wiring, other than adding the wiring there. And we're going to include a load though. So we're going to take an LED, and we want it to light up when the output is more positive. And so the long lead the anode to the output, short lead the cathode up 1 row, and then it can go down to 0 volts, just not all the way up to 5 volts. So we will take this jumper here, or this resistor here, 220 ohm, and anything higher will work perfectly fine. You can even go a bit lower, but it's limiting plenty of current. The LED just won't get horribly bright, and the resistor won't get horribly hot. That's the main thing. They'll definitely be bright enough. And now we have the Trimpot here, and so we're going to set the voltage we want with the Trimpot. The problem with using Trimpots or other resistor voltage dividers is that once you start powering something, once you draw current from them, that throws off the current going through the 2 resistive parts, if you're using 2 resistors, and throws off the voltage. So we're setting it now to the non-inverting input right there. I'll kind of space these out so they're not blocking other things. And all the inputs do, both of them, is look at the voltage and respond to that. And there is a very small amount of leakage. They try to minimize that the most they can, and the less leakage you need, the more different op amps you would have to look at. But if you can spare a little bit in comparison with the Trimpot, hardly any is getting into the op amp. So we will get a reliable voltage. So I turn the power on. The Trimpot is set all the way down. So now it is kind of glitchy. It kind of makes and breaks connection with the board from time to time. And so we may see kind of like brief flashes from the LED. But you see, we work our way up. Now the LED is getting brighter, brighter and brighter right there. And so we have 5 volts at the rail. So we can go from 0 volts to 5 volts with the Trimpot. And we saw the LED get brighter. The output though does not output the full 5 volts. I've been getting, I think it was 3.3 volts. So we have my oscilloscope here. So it has a connector right there with the cable. You power it down there, the power cord, and a little switch. We'll turn this on, and it's already set to the settings that I want. It's pretty easy to set these. The buttons, usually there's 2 options. So right there you can see we have 1 volt per square. If I press the button again, we have that. I can adjust where our 0 volt spot is right there. And up here there's a DC AC setting. If you put it AC, it tries to center the middle of the wave a changing wave. So we don't want that. I just have it at DC. And then I have it pushed forward so that what we see right at the beginning is the first reading, or the most recent reading that we have. So in any case, the other side of the cables comes to alligator clips, and let's kind of zoom back for a second. So I got the clips here. I like to just kind of stick them in the board. Luckily that went right where I want it, and that is causing not noise yet. If I don't plug this one in, if I plug the red one in first, so this is going to the output of the Trimpot. You can see a whole bunch of noise shaking around and stuff. The LED going a little bit. That's because we got the negative feedback. And plug that in and it should go away, but we may see little spikes and stuff. So this is kind of a good way to see if you're introducing noise to the op amp. But in any case, there we go. The Trimpot is set to 0 volts, and you can see it is pretty much spot on where that little marker for 0 volts is. And then each square going up is 1 volt. And so if I tap this, kind of shake it, alright, it's doing pretty good right now. Sometimes you really see a lot of little spikes. And the board is kind of getting worn. There's some spikes right there. So they were brief spikes, just misconnection somewhere. So the Trimpot's getting worn, and the board where I set the Trimpots are getting a little worn and whatnot. And so again, if that's a problem with a certain circuit, you need to address it. But there you can see we got the voltage. You can see it changing in real time, and it just gets a spec above 3 volts right there. And we had a little spike at the end. But there you can see that it's changing there. So we need at least 1.6 volts before the LED will conduct. And now you can see that in this area the voltage is not changing. We plateaued at probably about 3.1 or so volts, 3.3 depending on where the 0 volt spot is. And we can use a multimeter to check that better. But in any case, there you can see pretty clearly the voltage changes based in real time on the voltage that I'm setting to it. So it has negative feedback. The inverting input is looking at the voltage at the output because they're wired directly together. If it is lower than the non-inverting input, then the non-inverting input will tell the output to give a higher voltage. If the output and the inverting input have a higher voltage than the non-inverting input, the inverting input tells it to lower the voltage. So it's trying to keep the same voltage on there since we have feedback. Now, instead of just comparing the two and the output going all the way as positive or all the way as negative as it can, it's actually trying to balance them, and it does pretty good for the output there. And so in any case, hopefully that all made sense. This is one of my favorite circuits because you can pass along a weak voltage to an amplifier, and it doesn't amplify the voltage. We have the same voltage now. What it's amplifying is the current. We could not get the LED that bright if we set the op amp to, or the Trimpot here to that 3.1 volts. Let's go down, there we go. And so we're about 3 volts right now. This is a 10 kilo ohm resistor, and it's tapped into part of that resistance. So the resistance towards the positive side is, I don't know, maybe 3,000 ohms or something like that. A lot more than this 220 ohm resistor. So if we tried to power this directly, that resistance would, with a lower resistance as a load, it would rapidly drop the voltage. It would not hold the voltage steady at all. So it is just giving the voltage to the non-inverting input, and with the negative feedback, that's holding that voltage at the output. And so hopefully that all made sense. It's kind of easier to read in written form, but this is a nice demonstration to show it actually in effect. So the I'm trying to make this a 10-minute video. So this kit here, I'll link in the description. It has all these op amps, and I'm going through these op amps trying to find interesting things about them. Some of them, I'm pretty sure I fried. I miswired while I was swapping them out for other ones and stuff, and I accidentally powered the some of the pins that I shouldn't have, and so I think that's how I fried some of them. But I got some LF351s ordered, slow mail though. Who knows when I'll get them, if ever. And but in any case, this is the kit that I'm looking at. I look at what each one of these op amps is good and less good at and whatnot. This one, I'm really excited. It's a dual op amp, one that works with low voltage with a single supply. That's what I'm most interested in now. And as you can see, it works pretty nicely, pretty easy. And so if you just order these for whatever they are, like 50 cents or something, you can use them directly with the breadboard power supply that is commonly available everywhere. So anyways, hope you enjoyed the video. Thanks for watching, and I will see you in the next video.